So in problem number 29, we're asked to show that this cubic function has either no local extrema or two local extrema. The methodology that we use to find local extrema are taking derivatives, setting them equal to 0. So let's do that. Let's start this process off and say what happens when we take the derivative of both sides of this equation. And I see that I get 3a x squared plus 2b plus bx plus c.
Stephanie?
Hmm?
No, because it's, sorry, I'm sorry.
No, it's the last.
It's not December 1st. I was thinking it was December.
Right.
Oh, never mind. I'm going home to
Celebrate.
No, it's going to clean my carpet.
Oh, that sounds like
very sick.
that sounds like lots of fun. Right there.
Thank you.
All right.
Sorry.
Bye.
Okay, thanks. That's my student role today.
All right. Now, when
No, you're right. Yay. I was thinking it was December 1st.
when can that equal 0? Well, that looks like a quadratic equation. Right? It's a quadratic equation, and one way to solve quadratic equations is factoring, but we don't know any of these numbers, so that doesn't help. The other one is to use the quadratic formula. And if we use the quadratic formula, x is equal to the opposite of the coefficient on the middle term, plus or minus the square root of the middle term squared, coefficient squared, minus 4 times the leading term times the trailing term, and then this is all over 2 times the leading coefficient. So there's the quadratic formula. Now, what could happen? Well, this part right here either is positive or 0. Or it's negative. Okay, you remember this from Algebra 2?
Yeah.
Okay. If 2b squared minus 4 times 3a times c is greater than 0, there are two values of x that will make y prime equal to 0. Essentially, this quadratic, or the graph of that derivative, will look either like this, with 2 zeros, or it will look like this. Oops, that's the same thing. And now my eraser's working. Or it'll look like this with 2 zeros. Either way, you have 2 zeros, and you either go from negative to negative, or the parabola goes from positive to negative to positive. There are 2 zeros, and there are 2 sign changes, therefore there are 2 local extrema. Okay? If 2b squared minus 4 3a times c is equal to 0, there is one value of x that makes y prime equal to 0. Again, knowing that the graph of the derivative is a parabola, that would be equivalent to that situation, or regardless of whether it's either of these, this one goes positive and stays positive. There's not a sign change in the derivative. No sign change, no local extrema. Negative, negative, no sign change. That 0 exists. It's a critical value, but it's not, it doesn't lead to a local extreme. Last one, and I think maybe you can see where this is going. If 2b minus 4, 3a, c is less than 0, that means there's no real zeros for x. Those look like parabolas that never touch the axes. In which case they either are always positive or always negatives for those derivatives, no sign changes, no local extrema. So within the three cases, you either get 2 local extrema in this case, or you're in these 2 cases which give you 0 local extrema. Right? Now, can we produce in part B examples of both of these cases? Well, in this one case, you could do something like this. Let's have a cubic that crosses at -2, 0, and +2. Something that looks like that. What cubic would that be? That would be y is equal to x plus 2, x minus 2. How about for one of these other cases? Well, the classic one is just x cubed. It has a horizontal right at 0, but there's no sign change in the derivative, and so therefore there's no local extreme. And that's 29.